Dust to dust, ashes to ashes. Our technological civilization's phoenixes, serially arising from the ashes of their forebears. One of the recurring themes we see in humanity's traditions, be it our oldest myths or modern science fiction, is the notion that events tend to repeat themselves. This, of course, has a certain amount of truth to it. The sun rises and the sun goes down. A generation goes and a generation comes. What has been done is what will be done, and there is nothing new under the sun. And we do see empires rise and rise again and fall again, and on and on. And even our term for toppling one, a revolution, originates from that cyclic, revolving process. While each one is unique, we see many parallels and we tend to think all good things must come to an end. It's rather hard to argue that point, and even here, where we often examine ways in which life might go on long after our sun and every other star is gone, we do all inevitably slam into entropy eventually. It's been popular in cosmology too, both now and in the past, that while you can't beat entropy, there may be a grand reset button, some cyclic nature to the universe itself. We'll be discussing that briefly later, but let us begin closer to the here and now. In the past, when an empire collapsed, it wasn't really an earth-shaking event, and there were many other civilizations who kept rolling along, completely unaware of their downfall or existence. So too, in the far future, if we colonize the stars, it's quite possible that mighty civilizations may have come and gone long before most of the galaxy was even aware of their presence. We see something like this in Alastair Reynolds' novel The House of Suns. Yet at the moment, we do know of every human civilization currently in existence, and when one falls, everybody notices, and indeed it's entirely possible for them to fall in a way that literally shakes the earth. This is one of the categories of Fermi Paradox solutions we looked at way back in episode 4, Apocalypse How, that the reason we might not see alien civilizations out there is that they might wipe themselves out before they spread out to the stars. In that episode, we looked at 10 of the more common doomsday scenarios, but one of those was not technically a doomsday at all. Many had flaws, and some, such as artificial intelligence, simply saw humanity replaced by something else even more aggressive and expansionist, making them bad solutions to the Fermi Paradox. However, the notion of a cyclic apocalypse, that technological civilizations fall planet-wide and rise back up again only to repeat the fall, is an okay Fermi Paradox solution, but obviously not an end, or extinction as such, since the species just keeps running along. However, that running might be a bit like a hamster wheel, since you never really get anywhere, and differs mostly in that when a hamster finishes turning the wheel once, it doesn't get kicked in the face. Cyclic patterns to civilizations are, of course, hardly a new concept, nor is the idea that empires rise and fall, but generally we do get somewhere. There is plenty new under the sun. We have made vast technological progress no one ever did before, and that progress could all be lost in some global cataclysm, which makes folks wonder if maybe at some point in the past it already has. We see signs of this in archaeology and paleontology, which let us look back in the past and see many civilizations we never knew existed long before the era we usually call ancient. Yet it simultaneously shows us that this cycle did have a beginning. We know humanity had a beginning, we know there wasn't anybody building civilizations before us, and indeed we know that the Earth, the Sun, and even the universe had beginnings. Or we are fairly certain anyway, and we'll discuss that more in a moment. So too, while we know this universe began about 14 billion years ago with a Big Bang, and evidence tilts toward it ending in an expansive and cold time uncountable eons ahead, what we call the heat death of the universe, we don't know that this is all there is, or that this universe isn't just the latest version either. The notion is fairly simple. Humanity gets good enough at technology to pose a massive threat to itself, and blows itself up before getting out to the stars. But it doesn't quite wipe out everyone, and the survivors need a long time to rebuild. A time of hardship and privation, during which much of their knowledge is lost. But eventually they rebound and do it again, and again, and again. From a philosophical perspective, this becomes a bit of a Groundhog Day civilization, though not as extreme as some we've discussed, where folks are hitting a literal reset button to begin again for some simulation of the planet and its people in some era. Even if civilizations did this every 1,000 years for 1 billion years, you wouldn't see much actual repetition except in broad strokes, and that is a difference between a cyclic pattern and pure repetition. However, a problem arises in that after the first time, the game has changed a lot. For example, while there are alternatives to fossil fuels, ones that might even develop just as good and fast in their absence, they definitely shaped us and are obviously not available for a cyclic pattern. They take huge amounts of time to form, and we use them up a good deal faster than that, meaning iteration 2 of a civilization probably would not have them, nor presumably have to worry about its dangers for collapse. If a planet goes into a big climatic change from carbon dioxide and recovers in whole or part, that's pretty much a one-time problem, or at least one that can't recur for many future cycles. The simple existence of such fuels or ore deposits is a strong indicator we are the first advanced civilization to arise too, or they shouldn't be around. Or at least they wouldn't look like they do, as a hunk of steel that's rusted in 1 million years since someone used it still won't look like natural deposits, nor would radioactive materials have the elemental isotope compositions they do. You can make a similar argument about atomic power sources. Uranium is quite common, as these things go, at around a part per million in the Earth's crust, and we expect a fair amount in the mantle and core too, so it could be renewed a bit by volcanoes, but we have to enrich that to get the more rare isotopes out, as they decay fairly quickly. On the other hand, Breeder cycles that take the long-lived isotopes and feed them some particles to turn them into short-lived ones, options available to use with thorium for instance, offer far longer supplies. Indeed, by sheer total, a very long supply, but for mining purposes, it's less about total than totals of concentrated ores. The oceans contain an estimated 10,000 tons of gold, for instance, just floating around in the seawater, at a rough value of about $500 billion. Needless to say, nobody is really jumping to extract that. If a civilization flops over and has to rise back up again, it can extract resources from less ideal deposits, and for some materials, like aluminum or silicon, these are the next best thing to infinite. But for others, these lesser deposits aren't very economically viable. So we have a notion that perhaps civilizations that fail to get into space on round 1 or 2 might have exhausted the concentrated ores needed to get into space on later cycles. But this one at least can be dismissed fairly easily. The garbage heaps and junkyards of civilizations will tend to be rich mining sites should those ores run low, and you need at least many hundreds of cycles before you'd start running out of those construction materials. It's a little harder for things like oil and fissile materials, or even things like phosphorus, which we find concentrated, but then scatter out in fields to make our crops grow better. Concerns about peak oil have been around for a while, ditto fissile materials, but peak phosphorus has been getting more attention in more recent years, and more so quite recently, as we found that its production method in dying stars wasn't quite as we thought, and might make it far more rare than previously expected. We'll come back to this in a moment, but I wanted to return to how we know nowadays that we are the first civilization that I mentioned earlier. Simply finding bones of dumber creatures in the past doesn't prove there weren't smarter beings whose skeletons we haven't found. However, these days our fossil record is a lot bigger than it was a century back, or even a few decades ago, and there's fewer missing links or room for undiscovered large species. That said, we still only have a few thousand good dinosaur skeletons, ones complete enough for us to be able to get a solid look at the specific critter, and it is a family of critters that was around for almost 200 million years. The fossil spread isn't particularly even, but that implies for any given million-year period, we've only got around a dozen good fossil skeletons. And if you were just sampling primate skeletons for the last million years, and only had a dozen of them, you could miss Homo sapiens easily enough. Of course you probably would not. There have been way more of us than the other primates in recent years, exactly because of our technology. And we tend to intentionally fossilize ourselves via burial. If we all died tomorrow and raccoons emerged as a civilization in 10 million years, they'd be almost guaranteed to come across a cemetery, and suddenly have a fossil record just from one site, vastly larger than our entire dinosaur collection. More to the point, we didn't emerge in a vacuum. and even the dumber of our primate cousins has a skull that strongly indicates pretty high intelligence. Dinosaurs were hardly stupid, and indeed some species had fairly large brains as these things go. Nor is sheer brain volume alone much of an indicator, but proportion is a better one, and even sperm whales, who have the biggest by sheer mass, are only about 5 times heavier than yours or mine, while the body of a typical sperm whale outmasses us almost 1,000 to 1, and a lot of that brain mass is devoted to running systems that do rise with size. Proportion isn't ideal either though, as the shrew has the highest body-to-brain ratio, and while hardly idiots, they're obviously not as smart as chimps or dolphins or elephants, the latter two of which also have bigger brains than humans. Similarly, crows and ravens are fairly smart, but they have rather tiny brains, and cephalopods, like the squid, have rather bizarre brains that are hard to quantify. Indeed, we found a colossal squid some years back with a donut-shaped brain. So while it would seem unlikely we've missed smart dinosaurs, not finding the bodies of any who were part of some hypothetical advanced reptilian species, or even those ancestors who preceded them with larger brains, we can't rule that out just from looking at fossilized skulls. It's hard enough to determine intelligence in living creatures, let alone one dead so long that their bones are actually gone and replaced by mineral deposits. And of course squid don't even have bones and tend not to leave many good fossils. We can look at the cemetery though, we have them, and we've been burying people for a long time, and often with their assorted prized junk. Of course we've burned them a lot too, and while modern cremation incinerates even the bones to ash, early ones at lower temperatures usually tend to get the job done fairly effectively too, for the purpose of making them rather hard to identify. Every civilization is going to have a process for dealing with dead bodies, be it burial, cremation, or even cannibalism, as you can't just leave those lying around where they died, even if your culture regards corpses as irrelevant inconveniences. But those methods don't necessarily leave much, even in their primitive forms, that would help us identify them. So we cannot rule out ancient precursor civilizations like dinosaurs just from this either. Though it does let us rule out previous human ones, since we have tons of corpses we did bury sporting plenty of low-tech stuff, and it would be unlikely that those existed alongside high-tech human civilizations that coincidentally engaged in universal cremation. However, as mentioned, if you did find a cemetery, you know you've struck gold on a civilization, and not just from the many bodies in concentrated form, but everything that accompanies that. Even if they aren't buried with overt signs of technology on them, everything about such a place screams they did have technology. You've got the remnant fibers of clothing, which could include synthetic materials and metal buttons or zippers. You've got the box itself, which is pretty artificial in design, and most of these things are built with endurance against decay in mind too. And you've got the simple plots themselves. People don't die in neat, orderly rows 6 foot underground at a depth which would be confusing in terms of sediment layer dating. And those are the two big ones. Civilizations may leave a lot of junk around, but we also leave it in patterns that will stick out like sore thumbs. Whether or not they dispose of their dead in an enduring way, even our fields look obviously artificial from orbit. Plants don't naturally grow in nice rectangular fields. A skyscraper might fall over given time, but its foundation is going to last a very long time as a big, obviously geometric chunk of rock. Freeways might crack and crumble and end up as the base of a future river where they cut deep, but it's going to be very hard to miss running into those even millions of years later, and not seeing them for what they were, let alone just centuries or millennia later. We leave right angles and geometric patterns all over the place. Add to all that, we can see anomalies in sediment layers and more so in ice cores, and same as you can spot a big volcano or asteroid strike in those, we should have left a pretty big footprint on those if we ended tomorrow, even discounting that ending, which might leave tons of nuclear fallout in those geological layers. So we know if we want the first redoing high technology on this planet, and indeed we leave a footprint off-planet too. Stuff left alone in the higher orbits or on the moon can last a very long time and be noticeable, and our footprint in that extraterrestrial theater should only grow the longer we last, and in some fairly predictable ways. There's only one geostationary band around this planet. It is very useful, and its graveyard orbits are the obvious place to push decommissioned satellites. Similarly, the moon is a big place, and dust could cover over things to make them hard to see over enough time, but they're all craters where a technological species would be almost guaranteed to visit or build at. Down on Earth, rivers and coasts can change even on fairly short time spans, but the highest peak on the planet isn't going to change much, and you'd be able to visit a place like that expecting to find signs of someone climbing it for the prestige, and that's a fairly small place to hunt for signs of prior expeditions, ditto the North or South Pole. This is only in the long term again too. You would have to be blind and idiotic to miss signs of prior human civilizations anytime in the next million years from any doomsday scenario that would leave any survivors, short of a bizarre grey goo scenario that just happened to have safeguards against eating people or maybe living organisms, like a terraforming design, wrecking all our tech down to the bedrock so only us and our memories survived, and that would certainly leave a peculiar geological layer behind, and you'd kind of expect the survivors to make sure they recorded that event. So it's easy to lose lots of history, but pretty hard to wipe out the whole picture. Of course, someone has to be the first in a given cycle, and as we said earlier, after the first couple, there would be some key materials that were pretty much gone. There's still a lot of coal and oil left over, but we obviously have grabbed virtually all the ones that were easiest to spot and use. Here's the problem though, a collapsing civilization and those who live in its ruins are not an actual repetition of prior civilizations. You might need to be a genius to invent an internal combustion engine, but it's a very different story when millions of them are lying around rusting everywhere, and you've got memories and records of how they worked and what they were for. So you don't get civilizations falling back to hunter-gatherer level of technology, even if you've fallen back to those population densities. You could also fit just about every important bit of technology discovered prior to the 20th century into one shelf or chest of books, but even such time capsules or protected archives are overkill, because to rediscover atomic fission only requires one mention in a book or tale considered trustworthy that describes the process even in vague terms to give emerging scientists a huge head start or target. We've printed millions of periodic tables down the years, many of them laminated or otherwise made sturdy, and you're going to come across tons of those in a fairly recognizable layout that you can piece back together for a complete table, even if most copies decayed so this or that element was damaged or the text faded. Every corroded battery discarded, every appliance, every magazine, every trash dump carries instruction manuals for rebuilding our civilization. Just one semiconductor, disposed of in a way that makes it clear it was a vital component, is a huge clue to all of our electronics and solar power, and they're ubiquitous in all of those too, so it's hard to miss them. And you don't need fossil fuels or fissile materials to launch spacecraft either. Heck, one of our most common rocket fuels is liquid hydrogen and oxygen, or water that's been separated. You don't need oil to run a car. Ethanol is good enough, and we've been making biofuels for a very long time, longer than we've been digging that stuff up. It takes land you could be growing crops on, but not so much you couldn't have engines. It could be a problem if they did actually have to build up from square one again, since they'd likely be using all of their good land already for growing food. But first of all, you could still make a fair amount of the stuff, even if not as cheaply and abundantly as you need for lots of automobiles. And second, you are not starting from square one. Even a deliberate and systematic attempt to purge all records of technology, a process that would be nigh impossible, can actually only be done while using a fair amount of technology. How would anyone coordinate a global purge all the way down to our trash heaps and isolated cabins or outposts without a lot of technology? How would someone mangle your history so thoroughly that it didn't leave instructive clues without also eliminating the warnings of why not to invent certain technologies? You'd have to have a compelling reason that virtually everyone agreed with, that could be enforced long enough to remove the traces to make them hard to find, and which also warned people why they must not do it again. That, obviously, is where the cycle comes in. People forget why technology was bad and reinvent it. The problem is, the only way to do this requires such a systematic and coordinated approach, rather than it accidentally occurring from a natural disaster or man-made catastrophe, that it's implausible to believe the folks doing it didn't take that cyclic problem into account. I'm very pro-technology, but I also know the dangers of it, and if presented with compelling evidence that a given level of technology is inevitably catastrophic, say artificial intelligence, I could turn against it. You know, you barely survive one machine rebellion and decide it can never be risked again, but that if you keep your technology around, it will happen again. You decide what the safest level of technology is and aim to build that in as the cap. Again though, that's the problem. That's a decision, and one that requires coordinated and well thought out efforts. It's not a committee of wild-eyed zealots leading a purge and torching everything, because they'll ultimately fail with that approach long before they ruin enough stuff to knock us down more than a few generations of recovery time, and they'll miss books, many hidden or just lost. You need something sustained and coordinated, and that's going to be a committee that is carefully formulating a plan. They may even keep doing research in order to create things which end roads of inquiry, genetically engineering a plant that can be eaten to cure cancer, or act as birth control, or be ground up and distilled and stuck between glasses to act as a solar panel, or an algae that makes for a great and easy biofuel. They may even create ways to make very simplified computers you need to grow and assemble, or flat out code information into redundant bits of DNA. How would we react if we started finding obvious math coded into our DNA and that of other organisms, and broke that code only to find a warning that said, "Do not engage in genetic engineering"? All the while, they are sending teams out to erect ultra-durable monoliths with detailed Rosetta Stones engraved on them and warnings, the exact opposite of the ones from Arthur C. Clarke's 2001: A Space Odyssey, trying to dumb down cultures rather than push them along. They may even genetically engineer humans to be a little worse at math, or produce fewer savants and outliers, slowing progress so that longer consideration of the impacts of technologies can occur. They are not trying to destroy history, they are trying to preserve it to pass along the warning, and they're trying to create the highest living standard at the safest technology level they can, both because it's humane and to minimize the desire to disobey the rules and reinvent the stuff. They're playing the wisdom of the ancients card for everything they can, by leaving some giant graphene obelisk on top of mountains and the poles and so on, so that anyone getting to those places can't miss them and is confronted by an ancient and wise and knowledgeable society warning them about Pandora's box. And remember, that warning is one we all take to heart, and we've never actually been bitten by it. There are no fallen empires killed by their own technology in our past. Our ancestors tended to worship their ancestors as fonts of wisdom, and we know now they mostly were not, but we still take their advice a lot, and would more so if we had evidence confirming that desire that they were more knowledgeable than us. Now that could break down eventually, though if your Rosetta Stones are made enduring and numerous enough that they can't be missed, it might not, especially if you accompany that with a sustained technological level that can keep good records in history. In this regard, you could end up with a cycle where things got forgotten enough to encourage tinkering again, but as you did, you found more and more warnings about the dangers of it, and either backed off or approached it cautiously enough and forewarned of some dangers that you saw the trap in time and repeated what they did, complete with making new warnings. That's not terribly apocalyptic, but it could create a long cycle. As to how likely this is, that's just hard to say. We can make jokes about curiosity being dangerous and humans often acting in suicidal fashions to satisfy that, poking the big red danger button just to see what happens. But that joke is funny rather than grim black humor because we don't do it much, or rather we do, but as little kids. We all learn not to stick our hand on the stove and remember that when we grow up. The desire to stick our fingers into light sockets is wired into us, so we all know the compulsion and can smile at it, but we do resist it. And we do stick danger signs on stuff and pass on warnings to other people and down the generations. We also do learn from our history, albeit often not as quickly as one might hope. And we do address dangers to our civilization, though again, often not as quickly as one might hope. So it's an interesting case because there is something plausible about it. Again, not so much the constant repeating doomsdays, but more the notion that we might see a danger and conclude it's too risky and codify that warning, see it start to degrade, and then get reinforced once more after another close call makes it obvious there's a problem. In that regard, you could get cyclic civilizations easily enough. And they're not really repeating. It's not Groundhog Day any more than a farm is that's been passed down for 10 generations. I don't like the idea, but it's preferable to me over extinction. And while I don't think technology is going to result in that, I'm also not unwary of its dangers, nor utterly and dogmatically devoted to the idea that more technology is automatically a good thing. And I think that describes most of us. Technology is mostly good, but makes some more problems too. And more technology also probably good, but could expose us to some problems that might be more trouble than it's worth, or flat out suicidal. Again, not a big fan of cyclic civilizations, even if it wasn't actually repetitive, but there are worse options. I don't want our universe to ever end, but since we seem stuck with entropy, I don't mind the idea that it might reset someday, as better to ending and taking us with it. We're pretty sure that the anti-Big Bang, the Big Crunch, is off the table, with the cyclic bang option that it expands, contracts, and then bangs out a new universe again, but it's not completely ruled out yet, nor is a Big Crunch the only option for a universal reset. Even under the extreme expansion scenario, the Big Rip, it is possible that when that got to the point it was ripping quarks apart, that might regenerate things. After all, the weird thing about quarks is that they come in pairs, and to pull them apart means investing so much energy that when you break them, it's by creating 2 new pairs of quarks instead, potentially providing a sudden massive new wave of matter. You could also maybe see new universes popping out of neo-vacuum states as the universe thins out too much, or new universes spawning on the other sides of black hole singularities, or even the supply of dark energy, wherever it comes from if anywhere, run out and the universe stops expanding, either crunching again or just settling into a set size where all the extreme timeline reset scenarios like Boltzmann brains or universe-wide Poincare recurrence, the equivalent of shuffling a deck of cards so many times that eventually, and randomly, returns to its previous state, or one close enough to make no practical difference. Over infinite time, anything which can happen will happen, and that includes complete repeats of events. Endless places so identical to Earth that you could never tell the difference, and this probably has to be considered a cyclical apocalypse if it's happening, because nobody seems to be around from previous universes to tell us about them, so presumably there's no way to escape those endings, or at least travel into a new one. Though perhaps you can, but nobody did. So such cycles aren't just limited to hitting about our technology level and collapsing back down again. For instance, you might have a civilization effectively committing suicide by simply not caring anymore, and getting rebuilt by the handful of survivors who did care, and perhaps felt that way of life was essentially a poison that should not be drank from, and peeled back to a lower technological level. We'll be contemplating that some more next week when we go back to the post-scarcity civilization series to look at purpose, and ask what folks living in effective utopias do with their time and to give life meaning, if they even need such a thing, and what the consequences might be if it were absent. One of the key themes today, though, and in that episode on purpose, is the idea that folks could lose skills and might have to relearn them on their own from records. For basic survival or core science, I don't see that being a problem, but it's hard to imagine folks retaining how to make a website or do a 3D model, which can be pretty daunting to learn even nowadays. It's something I spend a lot of time thinking about while I work on this show, constantly trying to improve myself and the videos to better communicate ideas. Like so many of our modern skills, especially the technical ones that are constantly changing, it's not something you learn in school or can pick up an authoritative textbook on, but it's obviously important to running a channel like this. There are some options though. Lately I've been enjoying this great course from Kurzgesagt on motion graphics and animation over at Skillshare. Skillshare is an online learning community that focuses on assembling classes on technology and has courses on everything from making animations and graphic design to web development, so you can improve your skills, unlock new opportunities, and do the work you love. And a premium membership gives you unlimited access to those. Join the millions of students already learning on Skillshare today with a special offer just for my listeners. Get 2 months of Skillshare for free. To sign up, go to skl.sh/Isaac. Again, go to skl.sh/Isaac to get 2 months of unlimited access to over 20,000 classes for free. Act now for this special offer and start learning today. As mentioned, next week we'll be looking at purpose and meaning for high-tech civilizations. One of those might be exploring and colonizing the cosmos, and we'll look at that more the week after that when we return to the Outward Bound series to look at settling asteroids in Colonizing series. For alerts when those and other episodes come out, make sure to subscribe to the channel. And if you enjoyed this episode, please like it and share it with others. Until next time, thanks for watching and have a great week.